Hi everyone, so in the last lesson we reviewed right triangle trigonometry and we went over how to solve for a missing side length. Okay, so today I'm going to show you how to solve for a missing angle. So again, these problems will always involve a right triangle and it will also always involve one of the acute angles. Okay, so we're going to label one of those acute angles as theta. Right, so again, just to review, the side across from theta, we call that the opposite side. The side next to theta, we call that the adjacent side. And then we all know that the side opposite the hypotenuse, or I'm sorry, opposite the right angle, is the hypotenuse. Okay, so then we get our three trig ratios. So sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tan of theta is opposite over adjacent. So again, we use the saying SOHCAHTOA to help us remember our trig ratios. Okay, so let's look at an example for when we're asked to solve for an angle. Okay, so here in the triangle, they have the sides 9 and 14 labeled. They want to know what's the measure of angle A to the nearest degree. Okay, so A is the angle we're solving for, so we're going to call that theta. Okay, so 9 is the adjacent side. It's adjacent to angle A. And 14 is opposite the right angle, so that's our hypotenuse. Okay, so we're going to write down SOHCAHTOA on the side of our paper. All right, so the ratio that involves the adjacent side and the hypotenuse is cosine. All right, so we're going to set this up as cosine of theta, because we always do cosine of our angle, equals the adjacent side 9 over the hypotenuse 14. All right, and then to solve this, we're going to use an inverse operation. So we're going to do inverse cosine 9 over 14. All right, so here's what this is going to look like in our calculator. All right, so again, your calculator should already be set to degree mode. So we're going to type in second cosine 9 divided by 14. Okay, so they wanted the measure of angle A to the nearest degree, so if I round that, we're going to get theta is approximately 50 degrees. Choice C. Okay, so again, when you're solving for an angle, you're always going to use the second button in the calculator. All right, second example. So they give us the two sides and they want us to find the measure of angle A. So we'll call that theta. So 11.2 is opposite that angle. 18.3 is adjacent to that angle. So we're going to write down SOHCAHTOA on the side of our paper. All right, so the ratio that involves the opposite side and the adjacent side is tangent. So we're going to set this up as tan theta equals 11.2, the opposite side, over 18.3, the adjacent side. All right, and again, we're solving for an angle, so we're not cross-multiplying. Instead, we're going to use an inverse operation. So we want to do inverse tan of 11.2 divided by 18.3. So I'm going to go back into my calculator. I'm going to hit second tan 11.2 divided by 18.3. Okay, so in this question, they wanted the answer to the nearest tenth. So here, theta is approximately 31.5 degrees. So that would be choice A. Okay, so whoops. Third example is a word problem. So it says a communications company is building a 30-foot antenna to carry cell phone transmissions. As shown in the diagram below, a 50-foot wire from the top of the antenna to the ground is used to stabilize the antenna. Find to the nearest degree the measure of the angle that the wire makes with the ground. Okay, so here's the angle that the wire makes with the ground. So we're going to call that theta. Okay, so the side labeled 30 feet, that's opposite our angle. And the side labeled 50 feet is opposite the right angle, so that's our hypotenuse. So if I write down SOHCAHTOA on the side of my paper, we know the ratio involving the opposite side and the hypotenuse is sine's ratio. So we're going to do sine theta equals opposite over hypotenuse, 30 over 50. So again, we're using an inverse operation. So we're going to do sine inverse 30 over 50. So we're going to go to our calculator, hit second sine 30 over 50. All right, so they wanted this to the nearest degree, so if we round that, we're going to get 37 degrees. Okay. All right. Last example says Kayla was cutting right triangles from wood to use for an art project. Two of the right triangles she cut are shown below. If triangle ABC is similar to triangle DEF with right angles B and E, what is the measure of angle F to the nearest degree? Okay, so they're telling us the triangles are similar. So if the triangles are similar, we know that the corresponding angles have to be congruent. So they want angle F. So we know that angle F is congruent to angle C because the triangles are similar. So if I solve for angle C, that'll also give me the value of angle F. Okay, so in that top triangle, 15 is adjacent to angle C, and 17 is opposite the right angle, so that's the hypotenuse. So if we write down SOHCAHTOA on the side of our paper, we know that cosine is the trig ratio that involves the adjacent side and the hypotenuse. So we're going to set this up as cosine theta equals adjacent 15 over the hypotenuse 17. So we do inverse cosine 15 over 17. So again, we're going to go to our calculator, hit second cosine 15 divided by 17. All right, so to the nearest degree, we get 28 degrees. Okay, So if angle C has a measure of 28 degrees, then that means the measure of angle F is also 28 degrees because similar triangles have congruent corresponding angles. All right, so I hope this was helpful. I will definitely post a practice worksheet up on Google Classroom with some worked out solutions for you guys to try on your own.